Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and lately I've touched on a lot of fan topics, so we're going to keep in that theme, and I'm going to answer the question, what is system effect? The definition of system effect is the negative impact on fan performance that results when a fan is connected to a duct system. So fan performance data is developed under ideal lab conditions. This allows you to look at fan data and know that at a certain pressure and RPM, the airflow will be a certain CFM. But when installed in the field, the ductwork and installation conditions will be different from how it was tested. The difference is essentially the system effect. So let me draw a fan curve real fast. If you recall from the most recent fan curve podcast, the fan curve for a typical fan at a specific RPM may look something like this. We have CFM on the horizontal axis and static pressure on the vertical. Let's just put some tick marks here. Maybe this is 1,000, 2,000, 3,000 CFM and so on. And then up here, 1 inch, 2 inch, 3 inch, 4 inch, and so on. So the fan curve will look something like this for any given RPM. And then if you recall, I drew in a system curve. So the point where these two intersect is where the fan will operate if this fan is in this system. If the system has more pressure, the system curve may be up here, and the fan will operate at a lower CFM, or if it has less pressure, then it may operate over here at a higher CFM. When an engineer designs an HVAC system, they can calculate the system resistance based on how much ductwork is in the system, whether the airflow has to change direction, and other things in the system like diffusers and water coils and so on. Then they can calculate the system effect factor, which is based on the configuration of the fan in the system compared to the ideal situation, how it was tested. So I won't go into all this right now, but maybe that'll be a separate podcast. So anyway, the engineer can basically calculate the equivalent resistance in the system and use that to get the fan performance from the fan curves. And hopefully the installation was designed to minimize system effect as well. If the fan is installed differently from what was calculated, say maybe the system pressures are higher, then you'll not get the airflow you expect. A couple things can cause system effect. Poor inlet conditions, swirl at the inlet, and poor outlet conditions. So let me draw a couple of these out. Non-uniform airflow into the inlet will affect fan performance. So an inlet with kind of raw, sharp edges will have a worse inlet condition and be less efficient than one that has more of a bell mouth to it, where the airflow could come along the edges and into the fan. Also, let's look at maybe an inlet box going into the fan. So this is our fan, and our ductwork comes from up here, and we've built an inlet box, but it goes all the way to the floor. The airflow can come down, but down here in this bottom, you can get turbulent airflow where the air is going to swirl around and give you bad conditions. A better option would be a fan like this, and then with a nice kind of elbow coming in to direct the air into the fan. Another condition that can cause problems is swirling into the inlet. Let's draw just a centrifugal blower here, and the airflow is in this direction. Now if you duct in, it comes from the top, and now the air is coming around and swirling opposite of the airflow of the blower, you could have bad inlet conditions here. This is it's pre-swirling before it goes in the fan. If you come in from the other direction, it's in the direction of the fan. It's not as bad, but it's still not a good condition. Ideally, you'll put turning vanes in or something to straighten the air out before it gets into the inlet of the fan. Let's look at poor outlet conditions. What you don't want to do is come off your blower and then immediately tap off into two directions. The air is going to blow here and hit the opposite side of the ductwork and be very turbulent in this area. So I'll make a little bit of room here and show you. We've actually seen a condition where the outlet was ducted to several 90s. So if you look at it this way, it's discharging up. It actually came up around, it took a bend and then down into the building. So you can see the air's coming out of this. So the air basically had to come out of the fan. It came around, kind of hit this corner, and it had to make all these right turns in the distance of maybe 12 or 15 feet. So you can see this is a really bad condition where you'll have a lot of system effect issues. So that's system effect and what can cause it. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.